Okay, so please make sure, because we're going to probably turn this in later on for an easy grade, make sure that you have everything written down that I have so far. Okay. Let's see. An object accelerates if it speeds up, slows down, or changes direction. I promise you that that will show up on your test on Wednesday, which is next week when you're going to take it. So make sure that you can tell me that. Okay. State Newton's first law of motion. We've already done that, but we did add this, that Newton's first law is also known as the law of inertia. Okay. And so we're going to pick up with what is inertia. So that is number 6. Inertia is basically the tendency of an object to resist changes in its motion, okay? And the physical property that an object has that determines its inertia is mass, okay? So an object with more mass has greater resistance to changes in its state of motion, which means, bigger objects, it's harder to change their motion, okay? Which means that it's also going to have greater inertia. So more mass means more inertia, okay? And then this is actually part of lesson 3 on page 204. If I say inertia, I can kind of say that that's sort of like resistance. If I say inertia, I can say that's like mass. If I say inertia, I can kind of say that that's laziness, because things want to keep doing what they are already doing. They do not want to change what they're doing, just like people, okay? So inertia means just a resistance to changes in, in this case, a resistance to changes in its state of motion, okay? Okay, so we're now on the back looking at number 7. And it says to state Newton's second law of motion. And that information is on page 208 in lesson 3. Acceleration of an object depends on the mass of the object and depends on the net force applied to it. So 2 things determine an object's acceleration, and that's basically what Newton's second law says. Okay? So acceleration depends on mass and the net force applied, okay? Okay, so I've written down a statement for Newton's second law. Acceleration of an object depends on the mass of an object and the net force applied to it. Y'all know intuitively, meaning y'all know just based on common sense, that more force is going to give you more acceleration. So if you push on something harder, you're going to make it accelerate more than if you push on it, not so hard. You also know intuitively, meaning just by common sense and experience, you know that greater mass is harder to move. So more mass is going to lead to less acceleration. So bigger objects, if you push on a bigger object, it's going to accelerate less than when you push on a light object, okay? And the other thing I want you to realize is that objects always accelerate in the direction of the net force. So if you're pushing and the net force is, to the left, well, then the acceleration is also going to be to the left. But notice I didn't say that objects necessarily move in the direction of the net force. It's just that objects accelerate in the direction of the net force. And let me show you what I'm talking about. Okay, so this is part of lesson 1, and I'm on page 182. And I gave you 2 situations. Let's say you've got a truck that's moving to the right at a velocity of 25 meters per second. If you hit the gas pedal, then the force applied is going to be a force that's going to make the truck move forward even more. So the acceleration is going to be in the same direction that the truck's already moving. And because the acceleration is in the same direction as the direction that the truck is already moving, that's going to cause the truck to speed up. Okay? Acceleration is in the direction of the net force. Okay? Then you've got this other situation down here where you have the truck moving to the right at 25 meters per second, but this time you've hit the brakes. And the acceleration is going to be directed in the opposite direction, like against or in the opposite direction to the velocity. Now, the truck still moves this way, okay? But because the acceleration is to the left, what that is going to wind up doing to the truck is causing it to slow down. The truck doesn't move to the left. The acceleration is to the left, okay? Which basically counteracts the velocity that's to the right. And that's why the truck slows down in that case. But that's what I'm just reminding you to really be careful. Objects accelerate in the direction of the net force, but notice I did not say that objects move in the direction of the net force. That is a really, really important distinction. And think of the little truck situation to help you out. All right, so let's go on to number 8, and let's talk about Newton's third law of motion. Right here is actually the statement of Newton's third law of motion. When one object exerts a force on a second object, then the second object exerts a force on the first object that's equal and acting in the opposite direction. So forces always occur in pairs. For instance, think about a batter in a baseball game hitting a ball. The bat exerts a force on the ball, but the ball also exerts a force back on the bat. Forces always occur in pairs, okay? And the two forces in that pair, one force acts on one of the objects, and the other equal and opposite force acts on another object. So it's not like the equal and opposite forces are acting on the same object, but they are still equal and opposite forces. So sometimes Newton's third law is called the law of action and reaction, and basically sometimes it's stated for every action there's an equal and opposite reaction, and that's basically what this says. Okay, when one object exerts a force on a second object, then the second object exerts an equal and opposite force on the first object. Okay. All right. 9 and 10 we will probably address tomorrow in class because we didn't quite get finished. But just make sure you're caught up on what we did today, December the 4th, 2019.